on time. So.
All right, let's start. 20 people.
Okay, so thanks for coming, everyone. Today we're going to talk about hexagonal architecture, also called ports and adapter. So first, we're gonna do an introduction to the hexagon, show some example, and explain how to test this hexagon. And at the end, we will see some code with a serverless example. If you have any question during the presentation, you can just stop me anytime and I can answer. So first, what is the hexagon? Let's start with a quote from the creator. His name is Alistair Cockburn, and he say, hexagonal architecture allows an application to equally be driven by user, programs, automated tests, or batch scripts, and to be developed and tested in isolation from its eventual runtime, device, and database. So the goal is to clearly separate multiple elements of an application with a domain logic that's all the decision about the data we make related to business. And the use case it could be, for example, an HTTP endpoint and the device and services we use. That can be a database, a service, anything. So let's talk about the domain first. So domain is the application, and it's really centered around the business logic. And the code of this application could be, at some point, be read by a domain expert that is not a developer and can be understood. It's really the heart of the system, and it's why we're building the system. Now we have adapters. Adapters comes around all the dependencies we have on the application to be able to run. If we need to access data, if we need to send notification, if we need to request another service or anything that is out of your domain and that is a dependency. So we call those secondary adapters. We have also the primary adapters, that is a driver of the application. They are not dependency anymore, but they rely on the application and they will drive the domain. So you can have a HTTP handler, a CLI, a test. It can be an invocation from the console. It can be a GraphQL, many things. So we have two entities, primary adapters that drive the application, and we have secondary adapters that are driven by the application. So it's two different adapters, and it's a very important idea. And we have ports. We will talk about it later, and I think that's good for the adapters. So now let's talk about the ports. So in a normal world, you start with the trigger. You separate your trigger, your domain, and your database, and everything goes right until one day on a function that is related to your domain, you start to do a call to SQLize. And now your domain is tied to the database, and you cannot change the database easily because you will need to update the whole code base. You will not be able to change easily your infrastructure or any library you use. And maybe one day your domain and your function in your domain will throw an error, a 404 error in the domain. And now your domain is tied to the HTTP. And now we have a block, a domain that is not flexible anymore and is really tied to this infrastructure and its use case. While a domain should not be tied to that because it's just business logic and it's just related to how we manipulate the data. And that's why we use ports. Ports are interface. If you know a bit of programming, interface, it's like a plan that tells you how the interaction will behave and how a class will be constructed and define a contract. So you have the domain now that call an instance in what's an interface instead of calling directly a database. And that way we make sure the domain is not doing any call directly to an infrastructure related or expose like triggers operation. So instead of calling directly your database, you call through the interface you receive, and that's way you improve your boundaries in your system, and you like reduce the chance of someone doing a mistake and creating a big block of infrastructure application and triggers. So let's see some examples of Hexagon. So let's take a loyalty system. This idea comes from a project I've been working on, where you have a system that needs to apply promotions to transactions. So we get transaction from the store. We need to apply some rewards to those transactions. So at first, when you start to develop, you need to define what you will receive. So the use case here, it's apply reward at checkout. So you create a test case that is a primary adapter, and we'll call the port and inject your data in it. And then you have a system that needs to get some rewards. So you need to create a port to get the reward from somewhere. And you will get it from here, a DynamoDB table. Then you need to notify the customer. It's a new requirement. So you need a new port for the notification, and you need to get the notification from the adapter, the database, where you stock your notification ID, and send through the SNS, for example, here SNS, the notification to the customer. So we have like three entities, the use case that calls the trigger, the loyalty system that handles the data and take a decision, repositories to store the data and use it and retrieve it, and notification to send a notification. And at the end, you create your different primary adapters. That could be an API gateway or a specific one for admin. If you have an admin panel, you need to do specific operation. And yes, that's it for this example. Any questions so far?
No.
Okay. So how do we test the Hexagon? Before talking about that, I'm gonna explain what I call the pyramid of test. It's like a common, I think you've seen that everywhere. So the more you have unit tests, the more isolate is your test, and the more fast, because you don't rely on anything. It's just code that run, and it's really quick and really fast to develop. When you start to go into the integration testing, you may have some big payloads to generate, some infrastructure-related services, and that is more slow, and there is less isolation, of course. And end-to-end testing, it's like the ultimate kind of test where you have everything deployed and ready as like a production, and you test from the entrance to the end. So this is like very slow because you need to deploy, you need to run it, it depends on multiple interaction. And normally a unit test is about like a millisecond, and an end-to-end test can take minutes to run if you're looking. So we have the unit test, and on a unit test, we will want to test the loyalty system here. That is our domain. So we will have our test case that trigger the loyalty system through the ports using the same idea as a real use case that could be HTTP or anything, but it's just going to be a function call here. And we're going to use a repository. This time we use an in-memory DB database because we don't need to have a real system running. We just need to get information and to handle this information and to apply some rewards. And again, we need to check the notifications, and we will validate here using the in-memory notification service we create. Now we go over the adapters and adapters integration testing. So here we want to test the DynamoDB table and the adapter that implements the repository. So we will have our test suites that behave as a domain and invoke the function exposed in this interface and verify that our adapters is behaving as we want. Now we have the same thing for the other adapter, where we have a test suite that call the methods exposed in the ports. And we use contract testing here because before we had like a local DynamoDB table that is like a Docker we can run that is provided by AWS. So we can have a local Dynamo running on the computer. But for SNS, we don't have that. So we do contract testing. Contract testing is the idea of testing the protocol between your application and the service you want to request, because you don't really need to do testing on SNS. SNS is working, and you want just to make sure that you are calling SNS the right way. And we have also integration testing for your primary adapters this time, where you have HTTP contract testing again. We don't want to test API gateway. We just want to test our adapters that will take an event from API gateway and trigger a fake domain that will handle every action that can do a domain. Because to test this adapter, you don't need to know anything about the domain. You need to know what the possible actions the domain can return or throw or everything. And the same for the WebSockets. If we have a WebSocket contract, we apply that, we create a fake event and test the adapter. And now we have end-to-end testing where we deploy everything on the cloud, and the test case is using directly what's invoking the primary adapters, and we check the results in the system at the end. Is it clear for everyone? Do you have any questions so far? I'm going a bit fast.
I mean, I have a lot of questions, but
yes.
Should I go with my questions or you prefer later?
Let's see. We can go.
Okay,
Yeah,
so my first question I have, and like, what is a challenge we try to solve with Hexagon architecture? What didn't work, and or what do we try to improve with Hexagon architecture?
Okay, so the main like it's isolation. When we had the issue on bigger projects where we are tied to the infrastructure, and for example, if we want to change the ORM, for example, we use Sequalize on a big project we have, and today, if we want to change it, it's not possible. It's gonna take a month or two, and we want to make sure that this kind of effort is trivial and is not a challenge anymore. And the side effect of that is to improve testing, because again, if you couple everything together, you have a CI, and you will end up with like a lot of end-to-end testing, and those tests are not. It's very slow, very ineffective, and can be a challenge sometimes with fake negative and things like that. So that's the two main aspects we want to solve. Make it easy to test and create a great isolation so we can handle change and request from a client more easily. Does it answer your question?
Yeah, definitely. My next question, why is it called Hexagon? Can you a bit like...
Okay, just it's funny because it's just because of the shape is easy to draw. And like the creator in the talk about like he tried to do like a pentagon or other kind of shape to draw it on a board, and the hexagon was the easiest to draw. So that's why we call it Hexagon architecture. And it's also have another name that is like ports and adapters, but it's more, it's like less used.
And when you were using earlier domain, is it like what is it exactly?
So the domain is related to your business. So for example, if you have an order management system, the domain will be everything that is related to the order management side of it. If you have how to say, what else can we, if you have a video manager, the domain will be the video management. It will not be the infrastructure, and it will not be it will not be the detail. It's focused more on what you try to achieve and not in how you implement it. So the domain should be agnostic from technology and use cases.
I
So
see.
you can take it from a Lambda and move it to like a Kubernetes, or move it to like a regular instance quite easily.
And my next question, when should we not use Hexagon architecture, or by default, any software I design, I should keep in mind, let's start with an hexagon, or there's like specific case that don't bother with it, or just like what do you think?
So I think it depends on what is your like work habits. To me, I do a lot of testing and like TDD, and this architecture allow me to test easily and to be like more efficient, even if I have more files. And we will see a bit like in the second example that it's a bit verbose, but I think it totally depends on what you are doing. If you are working on a project that is not going to be maintained in the future, and it's not going to be a project you need to adapt every time to add new features, to be flexible, you maybe don't need to have an external architecture. You can just, if you run a script, for example, and the script going to be run one time and after you throw it away, you may not need to have that kind of infrastructure. But if you build a product and that needs to be flexible by listening to customer, new feedback, new features, I think it makes sense to use the Hexagon architecture.
Okay. Thank you, Jeremy, for the details.
No worries. And so now let's, so I think I went super fast, but we have like the hexagonal with serverless. So this will go over code. So people that don't want to deal with code can drop here. I think it won't be as interesting as before. And we use a use case. So this is kind of, we took a part of the subject we do to a new interview to expose. So maybe one of the engineers present here will have done that before. So it's a service that get the token like a crypto coin and returns the rain as a rate. So let's take, we start the project, and at the beginning, like the customer say, okay, we need an HTTP API endpoint to get the current rate of a token. So we will write our first Lambda. So we have the Lambda around. The Lambda is triggered by API gateway for the HTTP. We have an adapter that extracts the token name and invokes the domain with the token name. And we have the domain that's fetch the coin rate from an API. And we'll use like the interface to manipulate and to make the call to the API. So can you see the code here or not?
Yes, we do.
Yes.
Okay, perfect. So if we take a look, we have our, so this is a serverless application. I will give you the link at the end of the talk, so you can go and try to play with it. So we have a Lambda that have a handler, and So we have a get token here. We have a handler HTTP. And first, we're gonna build our crypto adapter. We always start with a secondary adapter. If we take a look, it's this one, the one that will be used by the domain. We instantiate it, so it's a coin layer. So we go to adapters, secondary, and we have coin layer adapter. And I think we should start with a domain for the demo. So we have a domain. The domain is get token domain here. That is defined here by an interface. It takes a crypto adapter and exposes a method that is, you get the token as a string, and you return a promise with a number or void. So we have a function get token. We have a constructor first that takes a crypto adapter and instantiate. We have a get token method that's called this adapter to get the rate of the token. If there is no token, we throw an error. Either way, we return the rate. And we have a crypto adapter. So because we need to do the get token rate, and this is defined by an interface here that says, okay, I need to have an adapter that have a method get token rate that take a string and return me the number, or undefined if there is none. So we have a coin layer adapter that implements this adapter. And here it gets the request, but it's for me because it was easier to test for the request. And handle a request using a get operation on this API coin layer, giving the token. And if it's a success, return the token rate, either way return undefined. And we have a test for this. Let's start with the domain. We have a test for the domain. And on the test, as I said previously, we don't need to give a real crypto adapter. So we just give a crypto adapter that implements the interface that have a method get token rate that take a token and return the rate of this token. So here I have a function that have like hard-coded rates and return the rate of the token name we receive. And after I instantiate my domain, and I do get token BTC, and I expect to receive 12. So I test the logic of the domain get token by providing an adapter that implements what is required by the domain. And that way I've tested the domain on its own. It's not tied to infrastructure. We don't rely on the API. We can test our domain without testing the API. And after, I need to check that the function should throw if the token is undefined. So I can just say that, okay, get token rate will return an undefined anyway. I instance new domain. I do the request and I check that it's true. So I don't have any dependency with the API. Now we want to test the API. We make sure that the adapter is working. We have covered, so this part here is tested now. Now we need to cover those two, the secondary and the primary adapter. So we can check the secondary. So we have, we went over it. So now let's see the test. So here it's a mock request adapter. It's the one for the request. I want to make sure that we receive the good URL to fetch. And I will do a contract testing by returning a payload that is the same as documented in the API and what we should expect from the API to receive to send. And as you see, so should return the current market rate of a token. I give some token, create the fake request adapter, create the coin layer adapter we want to test, and we check if the values are what we expected. So here we check that the value we receive is this one for BTC and this one for ETH. So now we have tested this part of the project. So we have the domain that is tested and the adapter that is tested. Now we want to check the API gateway adapter. So we're gonna go in the primary, and we have the adapter. So the adapter creates. We want to get from. We need to return the rate that is returned by the domain. So we have like the pass parameter. That's what we're going to give to this function. That is our contract generator. So this generates the API gateway event, and we're just gonna change the pass parameters because it's a GET request and it's the only thing that change on this event that matters for us. So we feed the pass parameter, it generates an event, and we make sure by using a fake domain that implements the same interface again, that the token we sent was the correct one. So okay, we say I want to make sure that the token we received in get token is the same as pass parameter token, and we return 12, and we make sure that the handler return a status cost 200 with a correct message body. This is a happy pass. Now we want to make sure that the handler is returning 404, and we do the same. And this time we throw an error from the domain, get domain, and we throw an error. This, we create the adapter again, and we check, we generate an event, and check if the message is what we expect, and 404. And again, 400, if the token, like if the request is not valid, so we have an invalid pass parameter, and we generate an invalid event, send it to the handler, and check that the validation is correctly done. And this is made in a way that we don't need to have the domain ready to test it. We can develop this on the side and not rely on what actually be the logic on this get token, which can just like fake it here. And at the end, if there is an error that is not unknown, we need to check that we return a 500 internal server error. And we do that by creating pass parameters that is valid. We throw an error in the get token. We don't know what the error is. We don't give any message, and we check that the result is 500. So now in our hexagon, we have everything tested. We have this part tested in integration, this part in unitary test and unit test, and this one in integration testing too. So I didn't do the end-to-end testing because it's very long to write and test. But if you want to fully have a test suite, you need to have one test that checks that if you call the API, it's calling the right adapter, that's calling the right domain, that's calling the right secondary adapter. And we end up with a file that is in handler HTTP, where we create the secondary adapter. So we give the request adapter, we give the API key, then we create the domain by giving the crypto adapter. And then we create the primary adapter that takes the domain, and we expose the function that will be called by Lambda to serverless. And that's it for the first Lambda. So now let's see what the client is going to ask. Now the client wants to have the endpoint available through WebSocket because one of their customers is only capable of using sockets on this application, and we need to expose that. So what's going to change? The token, the get token domain is the same. The crypto adapter is the same, so we don't need to change. We don't need to do anything else, but only this adapter change here. And we can cover the code, and on the adapters primary, we have a WebSocket adapters now. And these adapters take up is the same. It has a handler that take a message from API gateway, that is a WebSocket. And if we take a look at the test, we have we have a different event here. It's not the same as we used to have for the HTTP. We have a mock factory to create like socket adapters because we need to send a message to the client in case of error and to reply to the client also. So we check should send the rate if the message in the message to the toolkits. So we have a body. We generate a fake event. We have a fake domain, again, the same as before. And we make sure that the message that has been sent is the correct one. So we make sure we receive this message here. And we make sure we use the same connection ID as we received in the event. So, and we create the adapter, run the handler, and validate the return of the Lambda of the handler. And what it shows here, and it's maybe a bit different of what you used to have in test, is that I do the expect in the object I give to my adapter. So this adapter needs to have a socket adapter to be able to send messages. So it has a method send message. And instead of having to deal with a real like HTTP API gateway, not HTTP API gateway send message function, I validate using my specific class that used the socket adapter. And I can just do like here again, it's a contract testing. So I check that this function send message is correctly called with the right parameters and has the right message. So it's really becoming easier to write a lot of tests because you can factor and add the expect wherever you want. And that's why I like it a lot. Now we want to check for the error because the way to handle error with WebSocket is different than HTTP. And we want to make sure that we send a message, a success false, with a token rate not found to the customer. And again, it goes to the same principle with like the adapter. And we check that status code is 200 because if the Lambda fail, and we return an error to the Lambda, a 500 error, the Lambda will stop and be invoked again. So we will have a cold start. Same for, we need to send like a specific error because the format of the message we received is not correct. And again, the same, we check the message we send with the right connection ID. We have a domain that's returned undefined because we don't know, we supposedly don't know this token. And we check the return of everything again. And again, we have an internal error message and you give a body, we have an error, the same as HTTP. We had like last time an error we don't know. And this time we want to make sure the Lambda throw because internal server error means there is a problem with Lambda. And we want to invoke a new one. So we make sure it's raw. And I can show you the client adapter. So it's the one that's over the SDK. There's like post a connection and it's the same principle. We check that the data and connection ID are correct. And that's all we want to know. We need to know if our adapter, we send message and it sends correctly a connection ID and the data we want. So we have like the domain, the client, we do a send message, and it's gonna check the parameter, and that it has been called one time. And now, sorry, we need to check the handler, and we have the WebSocket handler, and those three source adapters and its domain didn't change at all. And we only changed the primary adapter. And now it's a socket. It's a WebSocket. And we changed and we expose it to serverless. So now we have the two endpoints ready, and we completed what the customer asked just by modifying a certain part and just the primary adapter for this case. Any questions so far? Before starting to going to the practice?
Nope, I guess I can continue.
Okay. So now it's your turn to wow. Oh, sorry. And now the customer come back to us and say, okay, the API con layer is too expensive. We're doing too many requests, so we want to cache the Lambda. So we're gonna do update tokens Lambda that runs every day. And because the free tier of like con layer is like 100 invocation a month. So we decide like, okay, we want the Lambda that run every day and update the rates. And so we have an update tokens Lambda now, another one that is invoked by Event Bridge. That is our cron task on the cloud. So we'll have a Event Bridge adapter. We need to get the data from the cloud, not from the cloud, from con layer API. So we get the tokens, and now we need to store the tokens in a database. And here we decided to use DynamoDB. So we have 4 entities now: Event Bridge, adapter, the primary adapter, the domain, the secondary adapter, crypto adapter to get the token rates, and crypto rates repository to store the rates in the database. And we can take a look at how it looks. So we go now in the update token. So we have the domain. The domain doesn't take anything, just get the rates from the con layer API and store it, save it in the database. So we have 2 dependencies here, the crypto adapter and the cache adapter. Crypto adapter to get the token rates. So we have a function that takes nothing and return a promise of rates. And we have update token adapter that update the tokens in the database. So it returns true or void. Wait, I think, no, we have crypto, yeah. This is the domain, and this is the secondary. Secondary to have save rates that saves the rates in the database and return true or false. So we can take a look at the adapters. Let's start with maybe the domain first. So we saw it. We can check the test because we don't need to have the other adapters ready to test the domain. That's one of the benefits you get also. So let's say we have 2 dependencies here. We have like the crypto adapter and the crypto cache adapter. So one return rates. So here we return the fake rates we have. And as a crypto adapter, we have a save rates function as defined in the interface that takes some rates. And we want to make sure we receive the same that has been returned by the crypto adapter. We create our domain, giving the new adapter we just created, and we make sure the function returns truth. And here we check that the rates are the same. So we validated our our use case and our domain here. Now, if there is no rates returned, we need to throw. And so the same, we have a crypto adapter that's returned nothing. And we have a crypto cache adapter that saves the rates. And we need to make sure that the Lambda is throwing and there is no rate saved in the database. And we don't have to have a real database. We use like the memory database we just created here. And now the domain is tested. So we can go over the secondary adapter. We have a con layer adapter that implements the crypto adapter. So it has get token rates. And again, the same principle as the other one. We're gonna check on the test that the URL is correct. We're gonna get and return the rates, and we can check the test. Up. Also, we have a contract because we don't have like a dev environment for this API. So we make sure the API is correct, and we return a contract that says that that is an event that can be returned by the con layer. And we make sure that the token rates return is a good one. So I could have factored that in a variable, but I missed it. We also check that the access key we sent was sent in the token also. That could have been in a variable too, but yeah, here we tested the adapter. Now we tested this adapter. Now let's take the crypto rates repository. This is like integration testing with the dependency on the Docker. So you have like a Docker file, Docker compose. Here, it's something provided by Amazon. It's just like going to create a DynamoDB instance in your machine. And I have an init function that creates a test file with some like fake AWS ID and a table name. And if we take a look at the table definition, we have a single table with like primary key, secondary key, sort key, and that's it. This is for our local infrastructure. And if we take a look at crypto rates repository, this time we don't mock. We use like the local DynamoDB we have. So we change the endpoint on the DynamoDB client and takes the table name for the environments. And we're gonna try our repository. So we do get save rates. So this method is not part of the interface we had because we don't need it in the domain. So if we take a look again at the domain and the cache adapter, we have save rates, but we don't have get rates because we don't use it here yet. So we just we just do the get save rates here. And that way we can test that we get the rate from the database. So we have after all, that's a trade you need to have when you run with a real database. That's state. So if you run your test multiple times, you need to clean after each test. And you can have conflicts between tests because if you're using the same table, multiple tests can run at the same time and they can conflict. That's why it's very important to test everything out in isolation so we don't have conflicts between tests. If you have a big project, you may have some conflicts sometime and it's never easy to fix them. It's really unpleasant. So we want to check that the rates we receive in parameter is saved to the table. So we have a crypto cache. We give the local document client the table name, and we expect the function to be returning true. We do get save rates, and we check that the data in the database is how we expect it to be. Here, I want to have like a partition with rates, and each sort key to be the token name and to have a rate, and it match the rate here. And so we tested this repository here, and now we need to check for the event bridge adapter. Event bridge, it doesn't send any events, so we can go on the primary adapter. So as you can see, let's take the handler takes nothing. It just calls the function update token, and it's true if there is an error. Or if there is an error, it's for the error. And you can add some logs later if you want. but just call the domain and throw if there is anything wrong with it. And we can check the test. So it's pretty simple. We have a fake domain again, and update tokens return true. So if the application return true, the function should return true also. It's kind of like a easy test, but it has to be done. So we check that the handler return true. And here, when the domain return false, we need to check that it's raw. So it's what we do here. And we check that the domain return true also when there is an error and non-error. And you could be tested your your log if you added a log or anything related to this specific infrastructure. And yeah, so again, the main point is to see like how you can use the hexagonal architecture to be able to run your test smoothly and to give like very specific interaction and operation without dealing with a lot of complexity, because here we don't deal with the complexity of the domain. We just take the adapter and we just test the logic related to it. And we can check the handler. So it has a secondary adapter with a request to get the conlayer API, the crypto adapter that will call the request, a document client from Dynamo with the right region. And this time we want to talk to the real database, a cache adapter that is our crypto rates repository, the domain, and the primary adapter. And I have a typo here, it should be event bridge, but we have event bridge adapter. And we expose the handler. So now we have built our Lambda here, and everything is tested on its own. We have the domain tested units with unit test. We have this part of the Lambda that is tested by contract testing. We have DynamoDB table that is tested like with integration testing with a local DynamoDB table, and we have event bridge that is like contract testing also using a contract that have nothing in it because event bridge doesn't send anything for that kind of event. And now it's your turn to update the first two lambdas. So to change here the call API we add to use the correct repository and use a table. So you will see that the domain doesn't change, the adapter doesn't change. It's just about this integration testing and these adapters that will change. So you have only one specific part of this lambda that you need to change to use a cache instead of the API. And so you have like the GitHub repository, it's public, and sorry. Here you can scan, or you can go directly on the address. I can write it on the chat. And if you have any question, we can like continue during like the 30 minutes we have after that. And you can try to change the adapter and see what the difference it makes to change like a completely different infrastructure on a small item, but still. And if you have any question, you can Slack me or just send me a message on one of those media. And I will give the link on the chat so it's easier. Let me go on GitHub. Do I have it? Wait, chat. Oh, thank you, Alexander. So it's there, and you can go and do the work if you want. And for the people that want to do a bit more, you can try to add a completely new business question that is a bit more complicated. That is like, can we expose the token rate evolution over the days? So you want to, you will have to, this is a new requirement and a new business logic. So it's the center of the Lambda that is, or the domain that is like updated. So a lot of things to change, and it's a good exercise to see how you can test and develop more complicated features. And that's it for the presentation. We can we'll just put a good picture so we can talk. Okay. Yeah, and if you have any question, you can feel free to ask, and we have, right, I think, like 30 minutes for that. Thank you for listening and coming.
You.
Thank you, Jeremy.
Thank you.
Thank you. It was very interesting.
Yeah, thank you.